Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 9.4, which is going to deal with normal distributions. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to use a normal distribution curve to estimate the percentage or probability that a set of data falls in between a particular range. So we're going to use the normal distribution curve to help us figure out what is the probability or percentage that something will occur between a range. Now, that's what we're going to look at for today in our lesson. Before we jump into our notes though, I just want to note that section 9.4 is the final section of module 9, and usually that means that a quiz is upcoming. But for the Module 9 quiz, we're going to add section 10.1 in. So instead of a Module 9 quiz, it's a Module 9 and 10 quiz. So we're not quite at the point where a quiz is upcoming tomorrow, but that we are on the horizon. So section 10.1, which we'll talk about next, will be the final section for the quiz. So with that said, let's go ahead and get into normal distributions for today. So a normal distribution, a bell-shaped symmetric distribution with a tail on each end, is called a normal distribution. So what does this look like? It looks like this. So the normal distribution curve, the smaller intervals are in symmetric bell-shaped relative frequency histogram. The closer the shape of the histogram is to a curve is called a normal curve. This little symbol here is going to represent standard deviation, and a normal curve has the following properties. About 68% of the data falls within one standard deviation of the mean. So one standard deviation means that we add the standard deviation or we subtract it, and in between either adding or subtracting one standard deviation, 68% of the data falls in this range for a normal distribution. Now, for this part, it talks about 98% of the data falls within two standard deviations. So it means if I add another standard deviation and subtract another standard deviation, 95% of the data falls within these two pens or this area. And then about 99.7% of the data falls within three standard deviations, which would be adding another standard deviation and subtracting another standard deviation from the mean. So 99.7% of the data occurs in this range right here. Now, that's all well and good, and that is helpful. But the next normal distribution curve that I'm going to show you is going to be the more helpful one for our notes today. So, this is going to be the normal distribution curve that we're going to use to answer our questions for today. So, the symmetry of a normal curve allows you to separate the area under the curve into 8 parts. So we have part 1, 2, 3, 4, 5, 6, 7, 8. And we know what those percentage or percent of the data is contained in each part. So we see that given by the 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15%. And that's going to be for the mean, and then 1, 2, and 3 standard deviations. Now, a few things to kind of indicate. This X with the bar above it indicates the mean. Now, the X plus this symbol right here is going to indicate the mean plus 1 standard deviation, plus 2 standard deviations, plus 3. For this way, it's minus 1 standard deviation, minus 2 standard deviations, and then minus 3 standard deviations. So we're going to use this normal curve to help us go through our problems for today. Now, what I suggest as you go through and do the homework, and I'll mention this again at the end of the notes, on the Google Drive page or the class website, I do have a Word or PDF document that has a whole bunch of normal distribution curves that you can print out and use to help you through the homework. Okay, I cannot tell you how important and helpful it is to use these normal distribution curves like this that is provided on that PDF to help you go through your homework. If you cannot find it, or if you would like it, just send me an email and I'll be more than happy to give it to you, or just let me know the next time you see me and I will send it your way. This is going to be extremely helpful, and I'm going to show you how helpful that is with example 1. So I'm going to go ahead and slide this on up, and we're going to take a look at example 1 for today. So example 1 states that the scores on a test given to all juniors in a school district are normally distributed with a mean of 74 and a standard deviation of 8. So each problem is going to give you a mean and then a standard deviation for that setup. So once they've told you the mean and then the standard deviation, as long as you are using the normal distribution curve, you're going to use these two to help set up your curve to then help you answer the different parts. So you're going to start with the mean, and the mean in this case is 74. And then your standard deviation is going to tell you what you have to add and then subtract. So if we start with 74, I'm going to add 8 to 74. So 74 plus 8 is going to give me 82. Then we're going to add 8 and we get 90. Then we add 8 again and we get 98. Then we're going to go from the 74, we're going to subtract 8 and we end up with 66. We subtract 8 again, we get 58. And then if we subtract 8 again, we get 50. So I've now been able to set up our normal distribution curve using our mean and our standard deviation for 3 different times. So now that I have my normal distribution curve set up, I'm going to show you how helpful and valuable it is to have this curve at ease of access or at the ready to answer these questions. So for this one, it talks about find the percent of juniors whose score is between 58 and 74. So what we are going to do for this is we're going to go to 58. So that's going to be our first spot. And then 74. So between 58 and 74. So that's going to be between these two pens. And we need to figure out the percent of juniors whose score is between 58 and 74. So as you can see, there's two sections, the 13.5 and the 34, that occurs between these two numbers. So what we're going to do with those two numbers is we're going to add them together. And that's going to tell us the percent of juniors that scored between 58 and 74. So we take 13.5 plus 34, and we end up with 47.5. And that is the percent of juniors that scored between 58 and 74. So as long as you have a normal distribution curve in front of you for quick and ease of access reference, this is going to help you solve your problems. Okay, what we just did for example 1, part A, that is what all of your work for today is going to be like. There's just different situations that we have to go through and interpret. We're going to use those to help us answer our problems for today. So, with that said, let's go ahead and take a look at our next part. So we need to find the percent of juniors whose score is more than 58. So we're going to go to 58. So 58 is going to be right here, and we want more. So we want numbers that are larger than 58. So we're going to go right here, and the numbers to the right of 58 are the numbers we want. So that means we're going to take 13.5, 34, 34, 13.5, 2.35, and 0.15. So we're going to add all the numbers up to the right of 58 because those are the ones that are larger or more than 58. So we start with 13.5, 34, 34, 13.5, 2.35, and then 0.15. So we're going to use those numbers. We're going to go through and add all of them up to then figure out what the percent of juniors that scored more than 58 on the test. So we get 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. And I forgot the decimal right there. And we end up with 97.5% of juniors who scored more than 58%. And 97.5 is our answer. And that is how we do section 9.4, dealing with normal distributions. So again, either you can go back and look at the notes to reference the normal distribution curve. You can always Google one, or like I said, it's on the Google Drive, or it's on the class website. Or if you need it, you can always just email me and I will just send it right away to you. It is highly helpful for you to answer these questions if you have it on a piece of paper to go through and set up and then use. So, with that said, that is how we do example 1. I do want to, just for matter of giving you more examples to look at, to take a look at example 2. So we're going to take a look at example 2, and then we'll wrap up our notes for today. So, with that said, for example 2, it talks about the mass in grams of pennies minted in the United States after 1982 are normally distributed with a mean of 2.5 grams and a standard deviation of 0.02 grams. So we're going to take our mean, and we're going to take our standard deviation, and we're going to set up our normal distribution curves. So our mean is 2.5, and then we're going to use our standard deviation to help us go through and set this up. So our standard deviation is 0.02. So we're going to take 2.5 plus 0.02. And it is not taking my decimal, so 2.5 plus 0.02, and we get 2.52. We add 0.02 again, we get 2.54, and then if we add it again, we get 2.56. Then what we do is we take the mean, our 2.5, and we're going to subtract our standard deviation of 0.02, and we get 2.42. We subtract again. We get 2.46. And then lastly, we end up with 2.44. So now that we have our normal distribution curve set up, what we're going to do is then go through and answer the 4 different parts. So for the first one, we want to figure out the percent of pennies that have a mass between 2.46 grams and 2.54 grams. So 2.46 is going to be right here, and then 2.54 is going to be right here. So we want to know in between these two, how many pennies have that mass. So the percents that we have are 13.5, 34, 34, and then 13.5 again. So we're just going to take those percents and we're going to add them together. So we're just going to add those 4 percents together, and that's going to give us our total for the percent of pennies that have a mass between 2.46 and 2.54. And when we add those together, that is 95%. So 95% of pennies minted in 1982 are between the mass of 2.46 and 2.54 grams. All right, so that is how we go through and do that part right there. Next, we are going to take a look at the percent of pennies that have a mass between 2.48 and 2.52. So 2.48 is going to be right there, and then 2.52 is going to be right there. So we end up between these two pens right here, and we have 34 and 34 for both of these. So we're going to do 34 plus 34, and when we do 34 plus 34, we are going to end up with a percent of 68%. And that is going to be the percent of pennies in 1982 that have a mass of 2.48 to 2.52 grams. All right, for our next one, so we're looking at percent of pennies that have a mass between 2.44 grams, so right there, and 2.56 grams. So we're looking between those two right there. So we have 2.35 all the way to the other 2.35. So we're going to do 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35. So again, we go between the two pens for this one. So the 2.44 to the 2.56, and that's going to include this area right here. So if we add all of these up, we are going to end up with a percent of 99.7%. All right, lastly, if we take a look at the percent of pennies that have a mass between 2.46 and 2.5, we're going to end up between these two pens. So we have 13.5 and 34. So we're at between 2.46 and 2.5. So that is this region right here. So the 2% that reside in this region are 13.5 and 34. And if we add those together, we get 47.5%. So 47.5% of pennies minted in 1982 have a mass between 2.46 grams and 2.5 grams. And that is our answer for the final part of example 2. Now, example 3 below this is just the same idea. In fact, it's the same situation, just different ranges and different scenarios. I'm going to leave that one for you guys if you want a little extra practice to see if you are on the right track. They are done on my completed notes, so by all means you can always reference them there to see if you are correct and if you have the right idea. Otherwise, I'm going to leave example 3 for you to do. If you have any questions or want me to run through that, in case you are wondering, just let me know and I'll be more than happy to do that for you. Otherwise, that is it for our notes today on section 9.4, dealing with normal distribution. Again, I cannot stress how helpful it is to either have a normal distribution curve in front of you with the percents, so you can write out the mean and then using the standard deviation 3 times, adding and subtracting, because that's going to make your answers and your solving so much easier. So, if you need a normal distribution curve, look on the Google Drive folder, look in the class website. You can always email me and I will send it to you, or just let me know the next time you see me and I will send it your way as well. So, with that said, that is it for today on section 9.4. As always, if you have any questions, you can let me know. By all means, take a look at my completed notes as you work through the homework. Otherwise, that is it for today. So have a great rest of your day. If you need help or have questions, let me know the next time you see me or via email. And I hope you have a great rest of your day. So I'll talk to you guys later. And have a good day. Bye.